Exam 4, problem 2. Now we have a 2100 kilogram truck traveling north 12 meters per second, turns east, and accelerates 15 meters per second. What is the change in the truck's kinetic energy? Well, part A is simple, right? I mean, because kinetic energy is straightforward, it's a scalar. Um, so the initial kinetic energy is 1/2 mvi squared, which is 1/2 times 2100 kilograms times 12 meters per second squared. And the final kinetic energy, 1/2 mv final squared. Final squared is 1/2 of 2100 kilograms times 15 meters per second squared. All right, let's get some actual numbers here. 0.5 times 2100 times 15 squared, and 0.5 times 2100 times 12 squared. So the initial kinetic energy is 151,200, and then 236,250. Joules, and 236,250 joules. All right, and so we're after delta K, which is just K final minus K initial. So 236,250 minus 151,2, so delta K is that kinetic energy minus that kinetic energy, 85,050. All right, that's change in kinetic energy. All right, part B is a little different. And part B is different because momentum is a vector. And so we have to take into account the directions, right? So first 12 meters per second north, then 15 meters per second east. We'll call north J hat, right? We'll call east I hat, and we'll write this down. All right, so the initial momentum, right? Initial momentum is 2100 kilograms because, well, mvi hat, not hat. What am I doing? I, because mv. Okay, right? Initial momentum is mass times initial velocity, but now because it's a vector, we have to stick in the fact that this is 12 meters per second in the j hat direction. And what is that in the end? 12 times 2100. 12 times 2100 is 252,000. 252,000 kilograms meter per second. J hat. Okay, so that's the initial momentum, and just have to take into account that it's a vector, right? So the final momentum, same thing, 2100 kilograms times 15 meters per second I hat, right? So now 15 times 2100, so 31.5. Okay. Same thing. What's the change in momentum, right? Well, right, final momentum minus initial momentum. So final 31.50 kilograms meters per second I hat minus 252,000 kilograms meters per second j hat, right? Okay, but because it's a vector, that's it. That's the change in momentum, All right, we can't reduce it any further, but it does ask for the magnitude, right? And so if we calculate the magnitude, well, what is that going to be? That's going to be square root of, right, 31500 squared plus 25200 squared. It's just using Pythagorean theorem. It's just adding, what's the magnitude of two vectors, right? So the magnitude of the change, square root of that squared plus that squared, and there we go, 340 kilograms meters per second. That's a magnitude of the change. Okay. And then direction of the change. All right? The direction of the change. Well, direction of the change is pretty simple. We have this vector. Here's the change in vector. The change in vector is 31500 in the I hat, and then 25200 in minus 25200 in j hat. So the direction of the change is in that direction, right? So we're going to take inverse tangent, or we'll start with a tangent and just write that tangent theta equals, all right? So tangent theta equals the 25200 divided by 31500, right? So theta is the inverse tangent. 25200 divided by 31500. Okay. So in Excel, a tan of 252 divided by 315, that's going to give me an answer in radians. So I need to take degrees of that answer. So 38.7 degrees, right? 38.7 degrees. All right, and the direction is going to be south of east, right? 38.7 degrees south of east. All right, that's it for problem 2.